Hello, good morning. Welcome to my YouTube channel. So in this video, let us discuss about active and passive elements as well as ideal and practical sources in electric circuit analysis as well as for network analysis. So active and passive elements means active means here it is used to supply the energy to a circuit and it can control the electron flow. So the component that supplies energy to a circuit and can control electron flow is called as active component. So here for all the electronic circuits as well as electrical circuits must contain at least one active component. So active component means it is giving supply. Either it may be voltage source or current source. Therefore, can see here the sources, the common examples for active components that includes voltage sources, either AC or DC, current sources, generators, which are active components, as well as all different types of transistors, such as BJT, MOSFETs, FETs, and JFET, and all the diodes also, which comes under active components. That includes Zener diodes, photodiodes, and Schottky diodes and LEDs. These all are comes under active component. So active component is nothing but a component which always supplies energy to a circuit, which will give power to the power supply to the circuit. And one more thing is passive component. Active means it supplies energy. Passive means it absorbs energy or else it receives energy. Therefore, the passive component is nothing but which can only receive energy and which it can either dissipate or observe or store it in an electric field or in a magnetic field. Therefore, these passive elements do not need any form of electrical power to operate. So this will only receive the energy, dissipates the energy, absorbs the energy, store the energy in an electric field as well as in a magnetic field, so that it doesn't require any form of electrical power to apply. And the next is, for example, these passive components cannot amplify, oscillate, or generate an electrical signal. You can see the examples are LC, resistors, inductors, capacitors, as well as transformers, which all comes under passive components. These are some few examples. So this is about active and passive components. Similarly, ideal and practical sources. So the source is nothing but either it may be voltage source or current source. Ideal voltage source or ideal current source means that the sources which are having zero internal resistances are called as ideal sources. So if it is a voltage source, internal resistors which will be connected series to the voltage source is always zero. If it is a current source, internal resistors which is connected across the current source which is always zero. That is called ideal. Practical sources means both the sources, voltage and current sources, are having internal resistance. For the voltage source, the internal resistor which is connected in series to the voltage source. For current source, that internal resistance is connected parallel to the current source across the load for both. So that you should know there are four type of sources. One is ideal voltage source, practical voltage source, ideal current source, practical current source. And we should know the ideal voltage source, as I told. An ideal voltage source is basically a constant voltage source that maintains a constant or fixed amount of voltage across its terminal or else across the load, no matter how much current that will be drawn from it. Whereas in a practical voltage source here, it is impossible to have an ideal voltage source. The output of real or practical voltage is dependent on the amount of current drawn by the load. So that all the practical voltage sources have some internal resistances that causes some drop in voltage due to the flow of current, and that internal resistor is connected in series with the supply. Therefore, the output voltage of ideal source voltage source is independent of the load connection, whereas the practical voltage source can be represented by an ideal voltage source in series with the internal resistance. We can see how it looks for ideal voltage source. The voltage source which is directly connected across the load, so that this output is not depending on the load, so that you are getting the ideal voltage, a straight line source voltage, and it will not affect any change of current that happens, whatever the current that flows to the circuit, and the voltage across the load, that will be always fixed. So that it is having the properties like an ideal voltage source has zero internal resistance, and also an ideal voltage source always maintains a specified voltage across its terminal, and the terminal voltage of the ideal voltage source remains constant even if the current drawn by the load varies or changes. Similarly, you can see for practical voltage source. As I told here, there is no internal resistor. Practical voltage source means a resistance which is connected in series with the ideal voltage source. So which means that the voltage, output voltage, that will be changes due to the change in current IL. It is not fixed, or else it is not ideal. Therefore, an internal resistance is connected in series to the independent voltage source across the load. Here the load which changes by changing the current that flows to the circuit, because there is a drop in internal resistance, that is IL into R internal drop. Because of that, by increasing the current, the source voltage is going, or else the output voltage is going to decrease, or else by decreasing the current, the output voltage will be going to increase. Whereas the source voltage is fixed here, but output is changing. Properties you can see, practical or real voltage source has finite internal resistance. It is connected in series to the independent voltage source, so that the internal resistance will be causing the drop in voltage, which depends upon the current drawn by the load. If current changes, there will be a drop. Due to internal resistance, the terminal voltage of a practical voltage source will be different from actual voltage source. This is how you should know the ideal voltage source and practical voltage source. And the next is current source. So ideal current source and practical current source. There, in case of voltage source, here there is no internal resistance connected in series to the source voltage. For practical, there is an internal resistance which is connected in series. For current, it is vice versa. An ideal current source is a constant current source that supplies same current regardless of the voltage across it and the load connected to it. Means for the ideal current sources, there is no division of current, a constant current that will be flows through the load. However, the current changes. That is however, the current supplied by the ideal current source remains constant. The voltage across it depends on the value of the load connected to it. Here, the current is fixed, voltage changes due to the load. Their voltage is fixed, current is changing. But the practice, you can see how it looks. Ideal current source means that here the internal resistance connected in parallel to the source current, or else the current source, where the internal resistance is infinite. Okay, there is no connection of internal, there is a open circuit, so that the source current, whatever which will be flowing, it is not dividing here, so that will be getting the ideal current source. And the properties here, the ideal current source which is having infinite internal resistance, whereas the voltage source is having zero internal resistance. You can see zero internal resistance in voltage source and infinite internal resistance in a ideal current source. And ideal current source produces specified current that is independent of the load. So the ideal current source is not depending on the load and voltage across the load. Whereas the practical voltage source So the practical voltage source is nothing but it is having a finite resistance, internal resistance that is connected across the current source. Means there is an internal resistance which is connected across the current source. So this combination is connected across the load. So you can see how it looks. See, there is an internal resistance which is connected across the load. So that by changing the voltage, the current is going to change. It is nothing but a practical current source shown as an ideal current source in parallel with the resistance whose value which will be equal to the internal resistance, a small amount of resistor. So that the following properties you should know for this practical current source. So it is having the high internal resistance, whereas the ideal current source is having infinite internal resistance. And here current delivered by the practical current source depending on the voltage across the load. Here it is not depending in the ideal source. The higher the internal resistance, practical current will more closely reaches to the ideal current source. Means by increasing the internal resistance, the practical current source will be closest reaches to ideal current source. Means if we increase the voltage, current source, the current flows to this load will be decreases. So like that it will happen. So this is about ideal current source and practical current source. So I hope you are understanding the concept. If you're having any doubts, feel free to write in the comment box. If you like this video, do subscribe and share maximum. Thank you. Have a nice day.